The ancestor of the modern trumpet was a straight horn that could emit just a few notes. By the 15th century, instrument makers learned how to bend the horn, allowing for more notes to be produced. The invention of the valve in the mid-1800s finally allowed the trumpet to play in any key. A trumpet is made up of 5 feet of tubing. 3 valves allow air to flow through additional tubing to alter the trumpet's pitch. Trumpets are made from sheets of metal, most often brass. This factory combines different thicknesses of brass in a single instrument to attain a particular sound. Workers first lay a template on a brass sheet and trace it out. Then they cut along the score line with electric shears. This piece will become the trumpet's bell. A manually operated press forms a perfect fold down the middle. Then they notch the edges. Then they close up the bell by hammering the notched pieces onto the opposite edge. They use a rawhide mallet because anything harder would damage the brass. A brass alloy is melted along the joint. It solidifies in a metal seam that permanently bonds the edges. Next, the bell goes over a cone-shaped mandrel, where the brass is hammered until it, too, is cone-shaped. Then the bell goes onto another mandrel mounted on a lathe. Here, the brass cone is refined into a more refined shape. Then the metal is filed smooth. Now for the bell's rim, called the bead. A brass rod with a notch at the end catches the edge of the bell and rolls it back into a rim. Metalworkers use what's called a concave roller to round the rim's jagged edge. Then they slide a brass alloy wire into the rim pocket. This makes the bell stronger and adds weight to the edge of the flare to project the sound better. They roll the rim over even more to enclose the wire. Now they heat the rim and apply acid flux to clean the surface for soldering. Lead or silver solder ensures the wire won't rattle when the bell vibrates. After wiping off the excess flux, the bell goes back on the lathe to scrape off the excess solder. Using an abrasive sponge, workers smooth away any scratches left by the scraper. Then they remove any solder bits trapped in the rim. Now the entire bell is filled with a soapy solution. Then it's frozen at -56 degrees. When the solution is frozen, the bell goes into a bending block. The frozen solution provides counterpressure, preventing the brass from buckling inward. And because there's soap mixed in, the pliable ice doesn't shatter under the pressure. After the angle of the bend is checked with a gauge, the bell is defrosted. In the mounting department, workers assemble smaller components made of brass and nickel. Valve casings, the sliding tubes to which they connect, the slide for tuning the trumpet, the pipe that holds the mouthpiece. Then they solder on the bell. They lubricate 3 pistons and install 1 in each valve casing. These slides have to be loose enough to move, but tight enough to prevent air leaks. One slide has a finger ring for holding the trumpet. After polishing and lacquering the brass, workers test the trumpet for sound quality. This is one company that likes to blow its own horn.